ఎత్తుకో పిక్చర్ లైక్ వస్తా సుధీర్
Yes, Pranav, you can start.
Okay, welcome, Pranav. Today's talk is a very interesting one. Please go ahead with your talk.
Yes, so today's
very interesting.
It's
Pranav,
called
it's very
clickbait.
interesting. Consciousness is subjective, science is objective. How they can
Yes. It's a nice clickbait. That's how I've come up with it. Anyway, so let's start with this topic, consciousness, goal of science. So today's topic, this consciousness is a word that everyone throws around. It seems that people seem to understand what this basic term is, but yet when people actually think about it, it goes around in circles and circles and circles without someone being able to properly define what consciousness is at all. So many people have thought about it. Many great minds have thought about it. I'm not going to define what consciousness is, but I will speak as to how today's science is set up so that trying to understand this consciousness, what is the way to understand it, what is the path to understand it, and science is set up along one such path, and it is in fact equipped to understand what this term consciousness is. So this is what I'll be talking about, and that is what I have as my topic here, goal of science. So as I said, it is supposed to be a goal. So if you know the end goal, then what's the point of talking about it? So the fact is, we don't know the goal, but we know that we have the capacity to reach it. So and how do we reach it? So that is what I'm going to talk about. So let me start off with what is the basic structure of any of any scientific field, be it chemistry, mathematics, physics. What is the basic way in which people explore the subject is what I'll talk about first. So we have our pet scientist / kid here, and he sees, let's say he sees these three objects. So he sees a river, he sees a lake, he sees the ocean, and he makes an observation. So there is something in the lake, there's something in the river, there's something in the ocean, and it seems that all these three seem to have some similar properties. So he makes a hypothesis next. So here the hypothesis that he makes is that they all have some similar properties. For example, they take the shape of whatever container it has. So the lake, the water in the lake is being filled up based on the shape of it. The river takes this kind of a shape. The ocean has this kind of shape. It's fluid. He takes a bit amount of water from the lake, from the river, from the ocean, and boils it, and he finds out that it boils out at 100 degrees Celsius, so on and so forth. And he finds out that they all have some kind of similar properties. So now he starts doing experiments. So what is that similarity? What is that similarity in the lake, in the river, and in the ocean? And he comes to the conclusion that the lake, the river, the ocean is built built up of the same kind of molecules, which is H2O. And he says, yes, okay, the water in the river, the water in the lake, the water in the ocean is the same because they are all built up of the same kind of molecules called H2O. So now we can take this analogy and say after an observation, he provides a hypothesis and he comes to the conclusion that water is made up of this molecule called H2O. And then our scientist friend right now, he's again curious. He wants to know what H2O is made of. So he goes again, explores, and he finds out that they are all made up of something called as atoms, and in the atoms there's a nucleus, and then there are electrons that go around this nucleus and so on. And then again he starts thinking about this, and he finds out that you can break this nucleus also, and you can again get a bunch of things. And then he goes, breaks that also, and he finds out he can get a bunch of things again and again and again. And this is how science evolves. So there's a guy who's always curious, and then he hypothesizes something, he makes some experiments, he draws some conclusion, and then the process again goes. So now, based on that conclusion, you put another question, and then based on that, you put another question, and so on and so forth. So this is how science evolves. And different branches of science occurs based on what kind of scale you study. So if you study the water at the scale of atoms, which is now not water anymore, but still. So for example, over here I have a picture of an electron. Then you call it physics. If you study at some molecular level, you call it chemistry. And then if you study over here at a very large scale, so this is a huge lake, and you see these interesting patterns coming out because of the nature of the landscape and things like that. And you call this field hydrology, and so on and so forth. So this is how science evolves. So now, if you look at any of these traditional approaches of science, it is always a bottom to top approach. So what I mean by that is that you always go down one step, find a commonality there, and then try to explain the behavior in the first step. So you start from a microscopic perspective and then try to explain how the macroscopic works. So it's sort of like building a house with bricks. So you first identify the brick as the element, as the smallest element. And then based on how you shape your bricks around, you can build different kinds of houses. And that is how science, that is the common traditional approach to science. You break it. So science is essentially like a cutting tool. So you break it into its individual components, and then you put them back together and try to understand how the whole picture works. So this is what I call as a bottom to top approach, where you try to understand the fundamental, the more fundamental units, and then try to understand how the big picture comes out or evolves out from these basic fundamental units. So an important point over here is to understand that this sort of science is like a cutting tool. So you cut it, and depending on how sharply you cut, how sharp your knife is, the more fundamental particles you can get. So the sharper your knife, you get electrons out. Some less sharp, you have chemistry and so on and so forth. So the way I like to put it is in this sort of this hierarchical picture, where you start off with a very broad understanding of science, where you are trying to understand how large groups of things behave. So over here we have, let's say, sociology is one field where you try to study a huge group of organisms. For example, how the collective human world works, and that is in the field of sociology. Now you break it down and you focus on one single organism. It could be a human, it could be a bacteria. It's just one single organism though, and that is mainly in the field of biology. Now you break apart that single organism and you say, okay, I'm going to break this organism again and I'm going to study just the individual components of that. And that is the field of chemistry, where you try to study molecules. And then you break that apart again and you see what is more fundamental than that. And you say, okay, it's particles, so and so high energy particles, and so like electrons and so on and so forth. And you usually put that in the field of physics. So there seems to be this hierarchical picture where you keep going down, breaking it apart. And this hierarchical picture is what I call as the search for fundamentality. So it's essentially you are breaking things more, you're breaking things more until finally you hope to find something very fundamental which can't be broken up again. So this traditional hierarchical picture is what I call as direction of fundamentality. But how close is it to the truth? How close is it to an indivisible fundamental particle, or an indivisible fundamental object, or an indivisible fundamental theory, is a big question mark. There is no way to understand that. But of late, science has taken a very interesting turn. So this hierarchical picture does not seem to hold. And I'll give you a very nice example that starts from the field of physics itself, where physicists are the ones who mostly believe in this hierarchical picture, and they are the proud ones who say we are doing the most fundamental science. But it is in the field of physics itself where we have found out that this kind of an hierarchical picture is not true. Cutting objects more and more finer and finer does not mean that you're going more and more fundamental. So one example I'm going to tell you is this. It's a simple example. So I'll try to I'll try to distill the science as much as possible without entering into any of the details. So what we have here is an electron, okay? So an electron has certain properties. So an electron, think of it as that kind of a brick, one brick. So in building up a house. So we have this one brick, which is this electron. Now, this electron has certain properties. So it has something called as a spin, this red color over here, arrow, and then it has something called as a charge. And because of this charge, it has certain properties. It kind of repels when another electron comes. So they don't like to. It's like two magnets. But if you hold the magnet in opposite ends and you try to bring the magnets close, they want to stay far apart, right? If it is the same end. If it is the opposite end, they want to attract, right? So it's the same principle with the electron as well. So you take one electron and another electron, they want to stay as far apart as possible. So now it turns out if you take one electron and then you take a bunch of electrons like this, the brick picture that we have, where you take one electron and you build the house by putting up different electrons, it does not seem to hold. It's not true anymore. In order to understand this bunch of electrons, you can't try to explain it in terms of these single electrons. So in principle, what it means is that you can't have this kind of a brick picture and explain that the house is made of bricks. You have to think of the house as a house itself. You can't break it into bricks and say, I made this house out of bricks. So what the interesting part over here is that So let's say you are trying to move these electrons through some material. It could be any material. For example, let's say, we have our phone, right? So in this phone, you can move electrons around. You can put a current. So when you put a current, there will be something called as a resistance. And you can understand a resistance as a simple model of a resistance. You can try to understand as this kind of a constriction. So when you try to flow something, when you try to flow an electron, it faces this resistance. It's harder to move in that region than the other region. And so in any material, these electrons will face this resistance. But there is this phenomenon called superconductivity, where all these electrons, they team up. They say, yes, okay, now let's all join, form a new kind of a state called it's a new state of electrons, where all of these electrons are interacting with each other, and they all have formed a new state. And they don't find any resistance at all when moving through this, when moving through this piece of a conductor. And so this material is called a superconductor. So like I indicated before, this sort of cutting it up and then stitching it back together does not seem to work here, because you can't explain the collection of electrons as a collection of individual electrons. You need to think of these collection of electrons as a collection of electrons itself. So this phenomena is what we call as emergent fundamentality. So we think, so all these years we thought electron is a fundamental particle, but now we have this collection of electrons, and in the superconductivity analogy, it's called as a Cooper pair. But that is the most fundamental unit there. So we can't think of these electrons as these kind of bricks anymore. There is a need for us to understand fundamentality in and not as individual particles, but as a picture of the whole itself. So over here I have this famous scientist, Phil Anderson. He's a Nobel Prize winner, and here at Princeton. So he's a very famous scientist, and he's one of the main pioneers of this kind of work, where he understood that fundamentality is different when you have more particles. And so he says more is different. It's not the same as the individual particles themselves. So this point is what I want to stress. The sum total seems to be more than its parts. It seems like 1 + 1 is not 2, but it's more like 3 or something like that. So one simple analogy, this is not a physics analogy, but this is often an analogy that I like to use. It's a cooking analogy. So it's like, let's say you want to make a dish, let's say sambar, out of these ingredients. So you have this bunch of ingredients. You have some dal, vegetables, salt, and so on. It's not the same. So when you finally make sambar, it's not the same as heating them up individually, mixing everything and putting it into your mouth, right? So there is something more when you make the dish out of all these ingredients, rather than just boiling all of these individually and then eating them together, right? So this is the point that I want to stress today, that there is this sort of emergent fundamentality in all of these sciences, and we can't think of breaking things up anymore. There is a need for us to see some sort of a fundamentality in the whole picture itself. So like I said, so it seems that growing the traditional hierarchical picture had this growing need of fundamentality, going down and down along this hierarchical picture. But it seems that that is not necessarily true. Biology will have its own fundamental picture, chemistry will have its own fundamental, and physics will have its own fundamental picture. For example, in physics, it could be a unifying quantum field. In biology, it could be explaining how neurons fire. In chemistry, it could be how individual atoms simulating how the conditions, how individual atoms join together to form the first kind of proteins, and thus the basis of life, and so on. So finally, what I want to say in this picture is that it is essentially this search for fundamentality that drives towards consciousness. So without uh, dealing with the actual property of consciousness itself, but it is what we can understand is that it is something that is fundamental, and with the recent developments, the fundamentality is not necessarily gained by cutting it more and more, but by trying to understand the big picture itself, but trying to understand that it can't be broken, it can't be solved, it can't be broken by again breaking it, but should and must be understood as a whole in itself. Yeah, so this is what I want to stress over here, that right now science is in a position where it has understood that there is this kind of a fundamental principle, there are these fundamental pictures in all of these branches, and it's not it's not coming up from a hierarchical picture, and it does not necessarily translate to cutting it down better and better, rather than viewing the whole process, viewing the whole structure as its own individual unbreakable element in itself. So now, how does this relate to our traditional spiritual practices? So I'm going to try to draw some parallels here. It's not necessarily a one-to-one parallel, but it is something that I find quite common and quite interesting. So spirituality also, I feel, is a search for this fundamentality, something that does not change, something that is indivisible, and something that forms the basis of everything. So I just want to quote this one shloka from Bhagavad Gita, chapter 7, and Krishna verse here says, "Yat gnatva neha bhuyonyat gnatavyam avashishyate." So it essentially means knowing which you don't have to know anything at all. So knowing which would put an end to all the things that has to be known. So this shloka for me is essentially saying that there is something very fundamental in spirituality that forms the basis of all knowledge. So how do I understand that? So I'm going to draw a brief parallel here. So the brief parallel for biology, chemist, this kind of a hierarchical picture where you have biology seemingly leading to chemistry, seemingly leading to physics. This kind of a hierarchical picture, I loosely translate it to the different paths in spirituality, which is bhakti, jnana, and vichara. It seems as though that bhakti is the path of bhakti needs some sort of a form. Jnana is rejecting these forms, and vichara is finally going beyond any form. So but it seems as though one is leading to another, and one is getting more and more fundamental. But in essence, this is not really true, because all of these paths lead to something very, very fundamental in nature. So you can call, Subhakti people can call it God, Gnana people can call it Atman, Vichara people can call it Brahman, but there is something very, very fundamental about all these entities. And essentially, all of these three paths lead to something very, very fundamental, and it's not necessary that one leads to the other, as it was in the hierarchical picture. I just want to share this one thing that I found in the Sadhguru teachings group, and I like this very much. So I feel it's very relevant here. Rama, Lord Rama asks Hanuman, how do you perceive me as? And he says, Hanuman says, so while I identify myself with this body, he says, I'm your servant. When I identify myself as an individual soul, then I'm your part. And then when I look upon myself as the eternal truth, he says, I'm the one with you. So this this for me is essentially this picture, where when you look at yourself as a body, then you find out that there is God in everything. You look at yourself from an individual soul point of view, then you are a part of the grand picture. And then when you are the truth, there's nothing else left but the truth. So over here, it seems as though science is completely disconnected from the spirituality, from these parts of spirituality. But that's not really the case for me, because all of them are looking for something fundamental. And right now, science has reached a point where it has been able to appreciate fundamentality in things on its own, as a collection, as a whole part, rather than breaking it up and then putting it back and seeing how it behaves. So it's come to a stage where it's able to understand that fundamentality is not something that you have to dig deeper, but rather you can appreciate it in different fields across different platforms by understanding it as a whole in itself, and not by cutting it and putting it back. So this is what I want to give as the main message of this talk. Let's try to understand. Let's be fundamental. So yeah, that's it. Any doubts? Any questions?
Wonderful talk, Pranav. Your topic is, misleading from the title. I was looking at a lot of, goal of the science and how consciousness is connected, and I was thinking a lot of things, but finally,
Pranav, can you remove that slide so that we can see your face?
That's okay.
Yeah. Can you?
Yes.
Yeah. So,
yes.
I understand what you're saying is there are, in a way, supervening orders of reality, and in any.
Sorry, can you repeat that?
What you're saying is,
okay,
let me 1 minute.
No, it's clear. I just didn't understand the super part.
So what you're saying is there are supervening orders of reality. So while physics is a reality and there is a fundamental aspect of all that reality is, chemistry is a different order of reality, and there could be different, and therefore
No.
probably you're saying.
I'm not saying chemistry is a different order of reality. I am saying that so the traditional approach for science has always been break and put up, break and put up. So in that sense, chemist or like we have this famous scientist. His name is Dirac. So he found out a very fundamental behavior of electrons, and he said with this one equation you can solve the entire of chemistry. So
Yes.
so this is part of this hierarchical approach where you think you have solved something very fundamental, and then now you can put it back as these kind of different bricks and try to understand the whole of chemistry, for example. I'm saying that is not the case now anymore. Physics has its own fundamentality. Chemistry also has its own fundamentality. What I mean to say is that you can't break it anymore and try to understand it from a picture of breaking and putting it apart. It comes from the fact that you have to appreciate the whole thing in itself. That is your final unit. That is your fundamental unit. There is no way you can break it up and understand. This is what I mean.
What you're saying is you cannot, the lowest aspect of chemistry is, for example, a bond or a molecular bond. So what you're saying is you cannot break it and find out more about how the bonding and life forming is.
No. So you can break. So of course you can break it, and that's how the whole field of physics is there. But you will lose some aspects of the whole when you break it and try to put it together.
Exactly.
For example, you can never try to understand, you can never explain this phenomena of what I call as superconductivity by breaking it into electrons and saying I put these electrons back together and try to find a resistanceless state. There is no way you can try to understand that.
That's
without
right. But
without
the point that you have brought up is
yes.
While you break up, you go into the world of physics. There are a lot of different things there, and
Yes.
the kind of study that you do of physics is no more the study in the field of chemistry, because the laws of chemistry are at a different level than the laws that you see. So these are supervening order of laws, and it's not that the higher laws are essentially made up of the lower laws, but any of the law underneath that, there could be a world. For example, underneath the world of chemistry, there could be a world of physics which its own, which is similar for us. We are looking at human behavior, whereas inside each human there are millions of organs and organisms, and they have their own way of looking at life. But what I really want you to ask is, tell us more is, how is this connected to consciousness? That I understand your bhakti gnana, that is the other domain. Even the way consciousness is being looked at, science in general and probably physics. How you are saying this is connected with consciousness at different levels of consciousness?
I can never do that because science by definition looks for something objective, and consciousness by whatever definition is completely subjective. So what I can say is, right now science is at a stage where we are able to appreciate something that is very fundamental in all of these different fields. Science no longer is like a cutting tool. It is still a cutting tool because any objective measurement is a cutting tool. But we have reached a stage where we have understood that not all of these phenomena is necessarily understood by a cutting tool. There is a need to understand the whole in itself using some other methods, of course. And there is a way to understand this whole picture, not by cutting it and and sewing it back, but by understanding the collective behavior of the whole thing on its own.
So when you say understanding of this, what you mean, one of those fields like physics and chemistry, or the entire phenomenon includes physics, chemistry, and all?
Yeah. So now this kind of understanding pictures on its own in itself is a different thing, because like in the example that I gave, it is within the field of physics in itself.
Okay.
You have an electron, you have a bunch of electrons. You can do the same for chemistry. You have a molecule, you have a bunch of molecules. You can do it for biology. You have one kind of a protein, you have a bunch of proteins, and so on and so forth. So this sort of emergent fundamentality comes at every scales, at every different order. So what I'm saying is, it is now in a position to appreciate this kind of an emergent fundamentality in all the scales. It's at a stage where we can find out that you can know at every scale there is something where we can't try to understand by breaking and putting it up. There is a need to understand it on its whole.
Correct.
Yeah, Pranav, this is Venkat. I sort of reading back to you. What you are taken as is 1 + 1 greater than 2. Basically, the emergent behavior. You cannot analyze it by breaking it, but rather you take that emergent behavior itself is open. Now the science figured out a limitation of cutting it is not going to help us understand the emergent behavior. Hence, we need to fundamentally study at each level, like physics, chemistry, and biology. The emergent behavior has to be, it's open now. The science is much more open than before.
That's right.
Understand this. I think you are expecting, it will eventually take us to the study of consciousness.
What I'm saying is, in our drive to understand this fundamentality, what I feel is a scientist is now able to appreciate fundamentality in everything. He's able to appreciate that taking things as a whole is the new perspective. So it's able to appreciate that there is something fundamental. There is something fundamental in all of these different scales, in all of these different fields. Now, do all of these fundamental things converge to something that science can never explain, according to me, because it will always look for something fundamental. So it's like having a scale. You're breaking down that scale. You find out that in that particular scale, you have to understand the group. Now you can take another scale and try to understand the dynamics in that scale, and you say, okay, this is the whole. But if you want to have the full picture, then you need to understand it at every scale, which is not possible for science. So, science, like I've always said, is a path. It's a sadhana. So this is a new perspective that a scientist can add to his understanding, and so that he can appreciate this fundamentality in everything, and appreciating fundamentality in everything, appreciating that there is something fundamental, that there is no longer a way to break and put it in. You have to understand the whole on its own. You have to appreciate the wholesome behavior is something I feel is a very big pillar in spirituality. And right now, science is taking us towards that.
Sure. Thank you, Pranav.
So, Pranav, very, very nice perspective. So from macrocosm, we are going to microcosm. Microcosm, we are going to back to macrocosm. Are you saying that?
We are going to back. Yes. From macro, we've always thought micro is the way to answer, but now we're going back to macro.
So micro to macro, when you go, then macro cannot be understood also.
I'm sorry, that is not clear. Can you repeat it?
From macro, you have gone to micro, but understand the behavior of macro. So then
It's
we have
still
come to
not clear. Is it a problem on
I
my
might-
side?
No. I think it's some modulation, Prabhuji.
Yeah.
So it's now?
No.
No, not able to hear. Is it clear to Shravan now? Anybody else? Venkat?
Yes.
It's better now.
Okay. So macro to micro we have come.
Yes.
Then you say micro doesn't give fundamental.
Yes.
So go to the macro again to get the fundamental.
Yes.
So now again we'll end up in a situation where macro also cannot be understood fundamentally, because anything what you do
Yes.
is
Yes.
a limitation,
Yes.
right?
Yes.
So is this, where does the what you call as unified theory of everything or unified field theory, does it fit into any of these discussions?
Yes. So in the slide I shared, like the physics seems to have something fundamental on its own. Biology seems to have something fundamental on its own. So this unified theory is essentially scientists trying to explain how the entire model of physics comes up with this just one equation. That is the
Correct.
unified picture. It's like so the one example that I gave to Shravanji, where Dirac said, with this one equation of electron I can solve whole of chemistry. So this is physicists saying, with one equation in physics I can solve the whole of physics. So the unified theory picture comes into.
So taking to the limit, microscopic level, we cannot get, as you go to micro, we cannot understand, we cannot get the fundamental. And the same way we go to the macro, we cannot still understand the full totality. So that
Yes.
means we'll come to a conclusion that we cannot understand anything fundamentally.
Yes, that is where science will lead finally.
Okay.
Yeah, you got it. Yeah.
Okay.
So science will always be left with a question mark, saying, I can't understand this, I can't understand this, I can't understand this. So this is like neti.
Okay. So then coming to Bhagavad Gita statement, by knowing which you know everything, what is that
Yes.
thing?
That you should ask Krishna Guruji.
By knowing that I can know nothing is knowing everything.
Yes.
Whatever I know, whatever I try to know, by my tools, instruments, whatever instrument I have, whether it's mathematics or sense organs or mind, whatever instruments cannot understand the whole.
Hmm.
So I'll come to a conclusion, I cannot understand the whole, then I know everything.
Looks paradoxical. You may have to explain it a little bit more. Yeah.
A wonderful talk, Pranav. You broke the science, made the science from macro to micro and micro to macro, integrated it again. Very nice.
Yes.
And very
So
simple.
this is-
Your sambar approach is very, 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 very meaningful.
Yes. So this is how I discuss with my mother. So she likes cook. She knows how cooking stuff works. So this is how I explain my science to my mother.
Yeah, that's good. So Prabhuji may want to answer that question of how knowing nothing means knowing everything.
So the challenge here is whatever I know, basically science is objective knowledge. And objective knowledge is like based on observation, based on inference, based on hypothesis, or based on mathematical models. So everything is nothing but a form, and the form is whatever you define in terms of form is still in the domain of appearances. And really, one who sees the appearance is beyond, is not you cannot put in the equation there. And the one who's whatever you do, the seer will be left out of the equation. That means the one who is making the inference is left out of the equation. So now, if you come to the seer into the equation, then what is seen disappears.
Okay.
So whatever you see is still in the domain of what we call as Maya or objective reality, which is actually unreal in Vedantic language. Unreal means it's just appearance. Today we have one scientist will come out with one appearance, one model. Another scientist will come out with another model. So ultimately, no model can explain the thing satisfactorily, because the one who explains it is left out of the model.
Yeah, that's probably what Pranav is also indicating, that each one has his own, each of these realms or whatever have their own limitations.
This understanding at any domain, any level will be helpful, useful, but not fundamental in that sense. The fundamental is always a perpetually elusive goal.
Yes.
Yes.
Because one who is observing it is always left out of the equation.
Yes.
And if you bring the observer into the equation, the observed is no longer there.
Observer and observed split is gone, then there's no
Split is
longer
gone.
anything. Yeah.
When the observed split is gone, then there's nothing to observe, then there's nothing to know, there's knowing everything.
Good.
Pranav seems to be not smiling or not responding.
Okay. Yeah. So that's the problem in the science, that science also says this, that the incompleteness theorem, or where there is always something that cannot be explained. But from going back to the earlier discussion, I also wanted to ask, there are some scientific theories which say the systems of systems behave in a different way than their individual systems. You have heard this? I don't remember exactly in where I've heard, but there are some scientists who are looking at the science of systems. So a particular system, for example, a human system is made up of several body parts, different respiratory system and things like that. So, but if you go into one of the systems, then the way it works inside is totally different from the laws of the higher systems and their functionality. And therefore, they're a totally different world. And they connect it to, what is that? Mandelbrot, some mathematical model is brought out on this. You're aware of that, Pranav? I thought you're referring to that.
No, I don't know that, but Mandelbrot, so Mandelbrot said, sir, I don't want to go into jargons, but it is something called as a fractal. So what it does is, the more you zoom in, the pattern repeats itself.
Yeah.
So I think I can put up a quick Google. Just go to Wikipedia.
Mandelbrot patterns depend on the first equation that you have taken and the given thing, and that gives a lot of patterns. Whereas if you look at the higher level, there are several things which will bring out several such equations. And their logic is totally different from within the thing. So some such, it is not exactly Mandelbrot, it was an example that they showed using that. So anyway, I let me dig it out, and I'll. This is about systems of systems. The research is about how there are constituent systems have totally different level of reality than the higher level of systems, and both are independent levels of reality, in the sense that the laws are totally different from one system to another system. Okay.
Okay.
As anyway, this is the one of the things it's a good topic for something, because there's a parallel thing of this science also in consciousness, where they talk about levels of consciousness. And I think Prabhuji knows this book called Spectrum of Consciousness, where somebody says there are multiple levels of consciousness, and each system of religion or science or whatever will fit into different levels of consciousness. And therefore, you can never study any one level, the entire level in totality, because you're looking into one system from another system. Okay.
So Pranav,
You
the question
can
is,
do that as your next talk.
Probably. I don't know. Okay.
so Pranav,
Yes,
the
Guruji.
micro behavior and macro behavior are different. We are speaking of. Will there be integrity of micro and macro anytime?
By integrity, do you mean like explain
There's a
like
one-
the brick and the house model?
Yeah.
Yeah. The brick and the house model is the traditional science approach. So, for example, explaining how electrons move in a conductor is actually explained by taking individual electrons and then understanding that there is no interaction between these electrons. So, like for example, in our mobile phone, it's not one electron, right? It's thousands and thousands of electrons. But we assume that these guys are all, the individualness of each electron is preserved in itself. And then we say, and then we have some ways to solve it. And then this has always been the traditional approach, where you build a house and you say, yes, I have a brick here, 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 and so on. And I built this house out of bricks. This is the traditional approach.
So are we saying that at any level,
Yes.
there's a different level of intelligence which will make the behavior, individual behavior and collective behavior different? Is there, we are bringing to the intelligence there?
If you look at it, everything is intelligence. So you can say there is infinite intelligence at every layer.
Okay. So when we say I am going to give a model, I'm going to give a mechanical model, which is not an intelligence model. Right?
Yes.
Whereas it appears that every level there is an amount of intelligence which is cooperating with other intelligences to create a more complex organism or behavior.
You can say that. So the way I think about it is that there are, so you take any at any scale, at any kind of a microscopic perspective, any model that you have is essentially distilling some small information out of that infinitely present intelligence, or the word you use in intelligence at that scale. You're distilling it and you're saying, this is what I understand.
Right. So the moment
if I take an electron, I am distilling what I know about an electron, and then saying an electron has something called as charge, an electron has something called a spin, there are so and so properties, and this is the model of electron that I understand. But now, now what you've done is you have put these electrons together and you found out that this model of distilling just one electron and putting one electron, and trying to understand how my house comes up out of these individual electrons is no longer a suitable method to understand. You need, for example, you need cement. You need the new thing. You need a new kind of cement that kind of washes everything away and says and shows that house is a complete house now. I can't see the bricks individually. It's made up of bricks, I know, but there's this layer of cement that has covered where my individual bricks are. And it's saying, no, you see the full house in itself. You don't see the individual bricks. So maybe you can take that cement as that extra intelligence.
Okay.
I think there's a Pranav. I think one observation, as Prabhuji also said, micro or macro, without accounting an observer, it always leaves that openness. It
Yes.
cannot go anywhere because you are analyzing half the setup.
That's
because
right.
the observer is not accounted. The most recent, because I've been following artificial intelligence for a while now, the three levels of artificial intelligence is, like directed, a task directed, like a chatting something. You can train some chat to, figure out the patterns and learn from it and respond to it. If you are a help desk chat, or
Right.
there is a chat GPT, the new,
Yes, I wanted to bring that up right now. Yes.
Chat GPT is a generic AI emerging because
Right.
it builds a common, a index or a structure to refine it based on my future input.
Right.
So that's a chat GPT is now brought in as a generic AI.
Yes, it's rendered teachers almost useless nowadays.
Yeah, exactly. It's very interesting. Interesting. This has emerged. Okay, the second generic AI has emerged.
Right.
Now the third one is a self-aware AI.
Mm.
This is the third horizon where I think the most closest experiment is this is exactly where because they figured out they cannot induce that behavior, that self-conscious behavior. Okay, that self, the I is not, they're not able to induce. Now there is a different path taken. They isolated neurons, put it on a petri dish, bunch of neurons. It's a combined. That's the moment you said, can we analyze together? These neurons started. They have a simple game simulated based on the, they give electrical impulse based on, yes or no. This is like a, bouncing ball game. If you combine and touch the ball, then you get a yes affirmation. Otherwise, wrong signal. It is trained so that these neurons started connecting, start connecting with each other to, they're totally easily, they started trained on the game. The combined behavior now started. So it may be, because there is no avenue to induce life. Hence, let's play with whatever the life form available and try to see they can collaborate and function. Maybe the future of the self-aware AI will be a bio plus computer. It will be a biobot. It is heading there. But it is interesting that what you laid out was that combined behavior is important. You can't isolate and study it because you don't get answer. Somewhere you need to combine. Maybe it makes sense. I think thanks for sharing this idea.
Maybe you can also give the next talk on AI. You seem to know a lot about AI in general.
So Pranav, does quantum physics, where the observation affects the observed, is it more holistic compared to macro to micro breakup? So
quantum mechanics is right now in physics. Quantum mechanics is like a tool. It has become a tool where without quantum mechanics you can't understand any of this. So the observer. So these kind of questions, the observer observed importance. It's not something that we really look about because we just take, okay, this is how quantum mechanics works. I'm happy with it, and we just use it as a tool and move on. We don't look into the philosophical aspects of it.
Okay.
Because it's too tiring and you won't get a PhD out of it.
Yeah, that is
But
non-consummate.
sorry.
Yes, Vasu.
The observer, randomly modifying the observed. That's why it is going nowhere.
So it's like so we have some theories. There are different theories actually. So the interpretation, it's not a theory, it's more of an interpretation. It's not so the one that you said is called as the famous Copenhagen interpretation. So this is what so I think they had a recent survey, and it's like around 45% of the physicists believe in this Copenhagen interpretation. Then there are other forms of interpretation. There's something called as the many worlds interpretation. So the idea over there is that the universe does not need an observer and an observed, but it's a many body universe. It's like many emerging universes, and the world seems to take one kind of an approach, and it collapses into our universe. So in that theory, there is no observer or an observed. It's just that the world is just leading, is just branching out, and it's just leading to what position there is. So that is another interpretation. And then there are other interpretations, Born interpretation, and so on.
Copenhagen interpretation? What does it say?
Yeah, so the Copenhagen interpretation, there are again multiple kinds of Copenhagen interpretations, but essentially what the Copenhagen interpretation says is essentially there is an experiment going on, and it's somehow tied with how do I put it? It's somehow tied to this observer. So without the observer, there is no measurement. So we call this. So this problem is actually called as the measurement problem. There is no one has solved it yet. There is no one to solve it. But it essentially says in order to have a measurement in quantum mechanics, there is an essential observer needed for a measurement to happen.
Right.
And then this is part of this whole measurement problem. I'm not going into details, but essentially this problem has not been solved yet. We don't know how a quantum mechanical measurement happens. When we observe, we don't know how that observation happens.
Okay. So that is the part of Copernican interpretation. And then other part is Copenhagen.
The other part, so because so there is this other person who came up. He said, okay, this observation principle is too complicated. So he said, no, there are these different fundamental realities. So it's essentially, so you can think of quantum mechanics as a superposition of two kinds of realities. It's like I am here and I am not here at the same time. Now, because I am a huge classical particle, I am always there. The quantumness of Pranav is very, very, very small, but the quantumness of an electron is not. So an electron has very nice finite probabilities of being here and being not there at the same time. So what he proposes is not an, so he doesn't, so for a measurement to happen, so you measure an electron and then you say, oh, 50% of the time you say electron was there, and 50% of the time you measure that the electron was not there. But before the measurement happened, what is the state is what people are very, very confused about. That this superposition of realities of whether there is an electron and there is no electron. How do you talk about it? We don't know. And when you measure, it collapses. It immediately collapses into either it is there or it is not there. And this part also we don't know how that happens. So one of the interpretations is that an observer is essential, which is the Copenhagen interpretation, for a measurement to happen. And the other interpretation is essentially that, okay, you don't need an observer. Everything is tied, and this whole grand picture of the universe itself, this whole universe itself has multiple realities of it's there or it's not there. And this act of measuring itself is encoded into it. And then the world just takes one kind of a reality and it says, okay, so suppose I measured an electron and I said, oh, I measured and I found that the electron is there. There is another total reality which is lost to us, where I measured and the electron was not there. So these are two different branching universes, and this universe never knows about this universe.
Are we speaking about deterministic universe?
Sorry?
Deterministic. Are we speaking about
Deterministic universe.
Like anything I measure is already predetermined.
Kind of like that, but there is no super determinism in this, because the whole picture is still a quantum picture. It's just that now where this universe takes us and how this universe takes us is not really important, because this observer and observed problem is kind of solved there. But yeah, it has all these other issues of what is the reason behind choosing a particular branch, and so on and so forth.
Are we coming to parallel universe theory because of this?
Yes, that's right. So this is called as the many worlds interpretation. So it's saying there are parallel universes essentially. And the universe where I measured something and I didn't find the electron, that universe is lost for me forever. There's no way of knowing about that universe. So it's like every second, every millisecond, there are these millions and millions of possibilities that has already happened, but I don't know about it at all. Every second, like the universe is just choosing some random thing and it's just going on and on.
So what is fundamental we are looking for? Where? In the present universe.
Yeah, so whatever we see, for us, whatever we can observe is what is fundamental, is where we can find fundamentality. So in the other universe, like we can't even observe, so there is no fundamentality. Yes.
Very wonderful talk, Pranav. Thank you.
So this is the other kind of interpretation that we have. It's called as the many worlds interpretation. But yeah, actually there are some people who are actively working on this field. There are some interesting experiments as well, where people are trying to say that Copenhagen interpretation seems to be more and more true, but there is still a lot of gap in the knowledge that we have, and this whole measurement problem is not at all solved. People somehow seems to have given up hope, because it all started because quantum mechanics was very new and people wanted to know what happens. But now quantum mechanics has become so ubiquitous, it's everywhere. It's become more like a tool now. We never question why 1 + 1 is 2. We never question why mathematics has to be right. So it's gone to that stage now, where quantum mechanics has become a tool. We just take it for granted. We don't question the fundamental principles in it anymore.
Quantum genetics, quantum physics, quantum chemistry.
Yes.
Apply quantum.
Yes. There is quantum everywhere. There's quantum biology, quantum chemistry. There's quantum everywhere.
Quantum spirituality also.
Yes.
Yeah.
So I think it's a wonderful evening and good, very good talk, Pranav. If there are any questions, I don't think there are many to ask. It's a wonderful talk. Thanks a lot for this talk, Pranav. Prabhuji, any last comment?
Even we can understand and ask some questions.
Yeah.
If you're talking a typical science language, we can't even ask one question. Now we have made things so simple, we can ask some questions.
Correct. Yeah, that's wonderful.
Everything you have brought down to sambar. And rasam.
Yes, everything is sambar.
Yeah.
Yes.
That's it.
Thank you.
Thanks a lot, Pranav.